All right, good morning, everybody. Welcome back to another video. Good to see you all. Hope you are all well. Where do animals go when their tails fall off? To the retail store to get retail therapy. Okay. Now, today we're going to go through a little bit of stuff that you guys have done before, but just never with trig functions and trig derivatives. Okay, this topic is kind of called the applications of differentiations. And so we're kind of looking at things like tangents and normals. And then also another application of differentiation is also the curve sketching. And so we'll get to that. Now, I actually, my calculator's run out of battery. So I'm going to do this all by hand and we'll see how we go. Hopefully it will work. Okay, so let's find the equation of a tangent. Okay, equation of a tangent, which means I'm looking at this y minus y1 equals to m x minus x1. That's what I need. Right now, that means I need a point and I need a gradient. All right, point plus gradient. All right, let me write and sorry, I'm a little bit scratchy this morning. Point and gradient, that's what I need. Now I've got one x coordinate. And so let's start there. When x equals pi on 6, y equals 2. I'm just going to substitute it into my original. 3, 10, 2 pi on 6. And so that's going to become 3, 10 pi on 3. And 10 pi on 3 by looking at my, that's not a great triangle, but I will work with it. Pi on 6, pi on 3. So 10 pi on 3 will be opposite over adjacent. Y will equal to 3 root 3, because that's 10 pi on 3. Okay. And so now I'm getting there. I've got a point. I've got a gradient. Oh, no, sorry. I've just got a point. Now, how do I find the gradient? Well, I'll need to use my derivative. All right. So that's my y dash is going to become. Now, remember, I've got 2x in my bracket, so that means that 2 is going to come out to the front as well. My derivative of my bracket, which is 2x, comes out. I'll get 3 times 2, and then tan will differentiate to sec squared. And then my bracket stays the same. So there's my derivative. My y dash. Oh my goodness, what's wrong with my voice today? Okay, so with my derivative, now I've got 6 sec squared 2x. Now, to find the gradient of my tangent, I'm basically looking at x equals to pi on 6. My gradient of my tangent is going to be 6 sec squared 2 times pi on 6. Okay, now let's clean that up a little bit. That's going to be 6 times sec squared pi on 3. And that's going to be the same thing as 6 times, and sec is 1 on cos. So I'm just going to write 1 on cos pi on 3, because they're the reciprocal function, cos squared. And so that's going to be cos pi on 3 is half. So it's going to be 6 times a half squared, which is a quarter. And so I'm going to get 3 on 2. That's the gradient of my tangent. Okay. Now, hopefully I've left just enough room. So now I can substitute that into my point gradient formula, y minus y1, which is going to be 3 root 3, equals to m, which is 3 on 2, gradient x minus x1, which was pi on 6. And, and if you just rearrange that, that should be more than enough to get us into something that we can work with. I'm just going to push that over to the other side. So y is just going to equal to 3 on 2x minus 3 pi on 12, which is pi on 4, and then plus 3 root 3, and that there, I'd be happy for that to be your equation of the tangent of y equals 3 tan 2x at x equals pi on 6. Okay, so a little bit of a process there, but we got there in the end. Now, your second application is your curve sketching. Now, we know how to do curve sketching. There's certain things like finding x-intercepts, y-intercepts, and also your max/min stationary points. All right, so let's apply that here. Let's start with our stationary points. So if we talk about our y dash, because we want to find stationary points, we want to let our y dash equal 0. So y dash sine would derive to cosine, and then cosine would derive to negative sine. Here's your y dash. Let's let y dash equal to 0. And so for here, we've got cos x, take away sine x equals to 0. Or in other words, cos x equals to sine x. And then if I divide through by sine x, or here, let's divide both sides by cos x, right? So that means 1 equals to sine x on cos x. Now we should be recognizing that this here is tan x equals to 1. And then if we look at our graph, when does tan x equal to 1? Luckily, I actually remember it's when x equals to 45 degrees, or in other words, pi on 4, going by our exact values. Cool. So we know that at x equals to pi on 4, we have a stationary point. And let's try continue with it. So if there's that there, I also need to find what happens at y. So at y, we have, hopefully you didn't hear my mom. Okay, and we've got cos pi on 4. Oh, sorry, sine pi on 4. Going back to the original. So that means y is going to equal to sine pi on 4 plus cos pi on 4. And that means sine is going to equal to 1 on root 2 plus 1 on root 2. And that means we've got y equals to 2 on root 2. There you go. And just to check one more, so that's our stationary point. Our stationary point is pi on 4 and 2 on root 2. Now, all I have to do is prove whether it's a max or a min. So for me to prove it's a max or a min, I'm going to do my second derivative. So my y dash was this. So let's take a look at my y double dash. My y double dash cosine. Again, don't forget your kind of nice little thing here. If I derive cosine, I get negative sine. So it'll be minus sine x. And then if I derive negative sine x, I'll just get negative cos x. So that would be my second derivative. And let's just check at x equals to pi on 4. I'll do a separate little thing here. At x equals to pi on 4, because that was where our stationary point was. We just test to see what happens. My y double dash here is going to be minus sine pi on 4 minus cos pi on 4. So it's going to be minus 2 on root 2, similar to before. And then that there is definitely less than 0. That means we're definitely concave down. That means we're definitely max. So now we know that we have a max point, and that stationary point there is a maximum. Right, and likely there will be a what do you call it? A hand sketch. So, and let's only sketch it between, let's go between 0 and pi on 2. So I'm just gonna not sketch the whole thing, but let's take a look. Let's see what happens at at x equals 0, at x equals pi on 2. So checking the boundary points. At x equals 0, y is going to equal to sine 0 plus cos 0. So that's just going to be 1. And then x is pi on 2. So that means if I substitute x is pi on 2 now, sine pi on 2, sine 90 is 1. And then cos 90 is 0. So again, it's also going to equal to 1. Okay, so we've got 0. We got pi on 2. And we know we're going to start at 1. And we also know we're going to end at 1. And we also know that we've got a stationary point, a max stationary point at pi on 4, which is right in between. And it's going to be 2 root 2, which is, in my understanding, greater than 1, because it's a max. Right, so that's going to be 2 on root 2. And so I can see there that that's going to be my graph just in between 0 and pi on 2. And so we have these tools to be able to help sketch these lines. Hopefully that helps. And all this stuff here is just going to be a continuation on what you already know about derivatives. So hopefully that makes sense, and hopefully you get it. If not, ask us some questions down below. Like and subscribe, and I'll catch you guys later. See ya.